Welcome back, guys. It's TheRealPsychMedia. This week we have chapter number 4, which is called Go Ahead, Be a Little Sensitive. So in this chapter, we're going to be looking at sensing the world around us, seeing things a bit more clearly, and then also feeling the heat, as in our senses, and also constructing your perceptions. So this first section, go ahead and be a little sensitive. We're going to talk about this idea of ontology, which is the branch of metaphysics dealing with the nature of being. And it has to do with the question of what is real. On the opposite spectrum, we have this idea of materialism, which is the belief that everything in the world is made of matter and of material stuff. So in this chapter, we see it is about the why and how of something that we all do, our senses, and how we perceive the world around us. So we don't really realize how important our senses are to us. These the sight, hearing, taste, touch, feel, and etc., those different types of senses. We don't truly realize the depths of these. So we're going to see that the study of psychology has to do with behavior and the mental processes, including taking a look at how our senses actually work. So how these senses actually work. So why is understanding materialism important? So the way we actually maintain contact with the information is through the metaphysical materials, or the actual physical materials that are in the world and consist within the world. So I do have this up on the screen, Karl Marx, which is the thought leader behind this idea of materialism. You always have to keep in mind that take everything with a grain of salt, because materialism isn't always the best thing for us. So now we're going to be looking at sensation and perception. Sensation is the basic process of receiving raw energy and information from our environment. So the basic process of receiving the raw energy and information from our environment, those are our senses. And then perception is the process of organizing and making sense of this raw energy. Alright, so this next section, building blocks, specifically our senses. We see that physicists and chemists have long pointed out that our world is made up of material stuff. So for instance, particles, atoms, molecules, and other forms of various energies. So i.e., the world is a big ball of energy where everything consists of a particular energy within that world. So the working definition of sensation is that the process by which we mentally acquire the information about the world through the reception of its various forms of energy. Okay, so these various forms of energy. Here are some common forms of energy: light, sound, heat, pressure, and chemical energy. Light is electromagnetic energy, sound is acoustic energy, or sound waves, and heat is thermal energy. Pressure is mechanical or physical energy, and chemical energy is just chemical energy, okay? So the building blocks for our senses, we see that there are 5 basic senses, which is sight, hearing, touch, smell, and taste. So sight receives light energy, hearing actually receives sound energy or sound waves, and touch receives mechanical energy, and smell receives airborne chemical energy, and then the last, which is taste, receives chemical energy. So this next section, the sensing process, we look at accessory structures. So our accessory structures, specifically the ears, the eyes, the skin, and the nose. And these provide us with access to our environment. Our brain uses its own form of energy, which is called electrochemical energy, which electrochemical energy is how our neurons communicate with each other and operate. We did mention this in chapter 3, so if you do want to take a look at that, go ahead. And then we see this idea of transduction, which is the process of turning environmental information into neural impulses in order for our brains to understand the various forms of energy that our senses organs receive, each form of energy has to undergo a transformation process called transduction. It's a transformation process called transduction. Just remember that. That turns it into electrochemical energy, okay? So then we see this idea from transduction to receptors, which receptors are sensory cells that make transduction possible. We're able to receive these senses with these receptor cells specifically. So receptor cells transduce and convert into environmental energy, and neural signal travels along the sensory nerve and taking information to the part of the brain that is involved in processing and analyzing the information. So receptors convert it from environmental energy into neural signals, and then that transforms into the brain, if that makes any sense. And then we're going to go take a look at the sensing process. Through this process of coding and representation of our brains, we're able to capture complexity of our environmental stimulus that we encounter. So this chapter is very huge on environmental stimulus. Everything in our environment, all the energy within our environment plays a key role. So the complexity of a stimulus is captured by the transition of different leisures into specific pattern of neural activity. So this is where we see the theory of specific nerve energies, which states that each sensory system provides information for only one sense, no matter how nerves are stimulated. So this idea of the theory of specific nerve energy states that each sensory system provides information for only one sense, no matter how nerves are stimulated, i.e. there are specific parts of the brain that will always label the stimulus they receive as light or as sound. So when a particular part of the brain is stimulated, the brain actually thinks that it's receiving sound or taste information from the sense organ, even if it is not, okay? So this is very strange, but we'll speak about this later on. If neurons in the visual system are activated, the brain senses light. Example, sunlight versus candlelight, okay? So then we're going to be taking a look at sight. All right, this next section is very important. It's called sight, which is one of the most important senses that we have because it allows us to have the ability to see, which is extremely critical to getting along in our world, in the world around us. So electromagnetic radiation is light, which is visible light, occupies wavelengths between 400 to 750 nanometers. This is how we calculate it, based on nanometers. And we see that light travels in wavelengths. So the intensity of a light is calculated by measuring the size of the waves, how big or small those waves are, as well as this idea of frequency, which is measured by how many peaks of a wave pass in a particular point within a specific period of time. So within a gap of time, the frequency of these peaks within that given time. And let's look at wavelengths, which allow us to experience different colors. So light enters the eye through the cornea, then light passes through the pupil, okay? Then the lens focuses the light onto the retina, and then the light energy is converted into neural energy, which is light transduction, okay? So let's look at this idea of retina, which retina is located on the back lining of an eyeball and contains special cells called photoreceptors that are responsible for transduction, which we talked about receptors being responsible for transduction itself. We also see through these ideas of photopigmentation or photopigments, which are broken apart when the photon of light travel in the light wave and make contact with them, okay? So this event starts at a chemical reaction, then that tells the cell to fire a signal to the optic nerve. So we can see that in the little picture description below where the optic nerve is located, that is where we're going to see a signal being sent to, and then it travels to the visual cortex of the brain. So the visual cortex is the part of the brain that is responsible for analyzing visual stimulus. Very important, okay? So the optic nerve, the visual cortex are very important, as well as the retina and understanding photopigmentation and how those work. So the two different types of photoreceptors are rods and cones. Rods contain a chemical specifically called rhodospin, which is very light sensitive, and this chemical actually reacts to very low intensity light and helps with our peripheral vision. So if you want to do any research on like how you can get better at your peripheral vision, just look into how you can consume certain ingredients that will help your rods and cones. So the cones specifically contain a chemical called iodipsin, which is responds to the different wavelengths of light and is involved in seeing color. So this next section is called Seeing Colors. We look at the idea of being colorblind or color blindness, which is the condition that means that the individual has a hard time seeing and sensing the specific wavelengths of light associated with the shades of blue, green, and reds. They lack photopigments, just as we previously talked about, that is sensitive to those wavelengths. So there are two basic theories of color vision. The first is the trichromatic theory, which is the idea that the retina contains three different types of cones, or photoreceptors, that each respond to different wavelengths of light, which in turn provides our environment or our experience of different colors. So there's these three different ideas or three cones within this specific theory. One is short wavelength cones, medium wavelength cones, and long wavelength cones. The short wavelength cones respond to light around 440 nanometers, which is blue light. The medium wavelength cones respond to light around 530 nanometers, which is our green light. And then lastly, the long wavelength cones respond to light around 560 nanometers, which is red light, each having specifically good benefits to specific stimuli within our body. The main premise of the experience of all the colors originate from these three basic cone inputs, okay? So the second theory that we see is the opponent process theory, which states that the brain contains different types of neurons that respond differently to different colors, okay? So we respond to different colors based on different neurons and stimuli. This idea, or the idea, is that these cells will fire more when compared to their baseline or background level of firing, and when stimulated by one type of light, and fire less when stimulated by another. So this is where we see the negative after image effect being taken into play, which is the effects of the images in your mind's eye are in different colors than the actual image. So this is where we see the idea of color blindness. It's because of different stimulus and stimuli, and these are two different types of theories that we see in this book. Figuring distance. How can we tell how far something is away from us? By just looking at it. So the depth or distance are calculated by our visual system using two inputs specifically, monocular cues and binocular cues. Monocular cues, we know that some things are bigger than other things. That's our perception and understanding that we know some things are bigger than the other. The rule is that the things that cast bigger images on our retinas, that's what the rule is. We see certain things, they cast a bigger mass in our retina as other things. So the binocular cues depend on having two eyes that provide information to the brain, which is convergence and stereoscopic vision. Convergent refers to the information provided by the muscles of the eyes to the brain to help calculate distance. From the eyes to the brain to calculate distance. Eyes pointed inward towards the nose, the brain knows something is close to you. Eyes pointed outward, the brain knows something is farther away from you. So this idea of stereoscopic vision, which is the ability of the visual brain to register a sense of three-dimensional shapes and form from visual inputs. Alright, for our next sense, which is hearing. Hearing, the sound travels in waves and is measured by its amplitude of the wave size and frequency or number of waves per unit time. So each of these translate into a psychological experience. Amplitude, which is equal to determining the loudness of something, and frequency, which provides the pitch or tone in which that specific thing is being heard. So structures of the ear are specifically designed to transduce or convert sound wave energy into neural energy, okay? So as the wave passes through the ear canal, it eventually reaches the eardrum or the tympanic membrane. The vibrating eardrum shakes three little bones, the malleus, which is the hammer, incus, which is the annual, and the stapes, which is the stirrups, which amplifies the vibration within the ear for you to hear. After the sound wave reaches the inner ear, or the cochlea, auditory transduction occurs. The cochlea, which is filled with a fluid, is a floor and lined with a basilar membrane, which it has hair cells that are attached. Specifically, these hair cells actually are able to hear and sense specific fibers and energy waves. The sound waves coming into the inner ear change the pressure of the fluid inside the cochlea and create fluid waves that moves in the basilar membrane. Okay. All right. So this next section of senses is touch. So the sense of touch is sensing pressure, temperature, and pain. Specialized cells in the skin sense touch, which sends a signal to the spinal cord and then on to the brain. So from the spinal cord to the brain. From the skin to the spinal cord to the brain. When heat, cold, or weight stimulates touch receptors in the skin, this then sends a neural signal towards the brain, and then the pressure leads directly into neural signal. So this idea of pain is a special case for the sense of touch because it would be hard to avoid harm and survive in this world without the sense of pain. So that we need something to let us know that something else could harm or damage us. So pain is an important signal for something that could help us from preventing or destroying our body or getting in a situation that could do that. So there are specific fibers, which A delta fibers and C fibers. These are two specific nerve fibers located throughout our skin, signal pain to the brain. Okay, so A delta fibers carry sharp sensations and work rapidly, sending signals to the brain. The C fibers send signals of chronic and dull pain and burning sensation. And then this is where we see the gate control theory of pain, which states that the pain signals must pass through a gate in the spinal cord that decides which signal will get through the brain and which one will not. So if another sense is using the pain pathways, the pain signal may not reach the brain, so it will be avoided and a different signal will occur. There might be competing signals coming from another body part toward the gate, thus inhibiting the pain signal from traveling up the brain. This next sense is smell and taste, where we see olfaction, which is our sense of smell. Volatile chemical particles this is something that we see. So volatile chemical particles are substances which is one that readily turns to a gas at a lower temperature, such as alcohol and gasoline. So inside our nose there are thousands of olfactory receptors. These are specific receptors. The molecules from the volatile chemicals cause a chemical change in the receptors in our nose, which sets the transduction process in motion. Transduction meaning specifically the sensation of the receptors. The chemical energy is then converted into a neural energy by the receptor cells, and the signal is sent to the olfactory bulb. So that is where the signal is then processed. So the olfactory bulb is a rounded mass of tissue that contains several types of nerve cells that are involved in the sense of smell and emotion. Smells can activate emotional memories from time to time. So specific smells, maybe a dish that you made previously that reminds you of your childhood. And these are based on this idea of pheromones, which is sense that animals send out signals to other animals during mating season. They say that this may occur in humans, which predominantly does, but it's primarily in animals, but they are speculating on whether or not this is something that we do as well. So there's this also idea within smell and taste called gustation, which refers to our sense of taste. Taste is a chemical sense made possible by the chemical receptors on our tongues, known as taste buds. So there are various taste variations, which is sweet, sour, bitter, and salty. And we see that there are over 10,000 taste buds, okay, which is pretty cool to see. So we do have a lot that we are lacking because of the excessive amount of stimulus in our world. The taste buds then react to molecules of the food, which again convert chemical energy into neural energy and sends that information to the area of the brain involving in analyzing taste information. So this is taste and smell. Alright, so this next section, finishing the product of perception. Perception is the process of organizing and analyzing and providing meaning to the various sensations that we are bombarded with on a daily basis. So sensation provides us with raw materials, and perception is the final product of those sensations. So we see different types of view of perception, which is an ecological view, which states that our environment provides us with all of the information that we need to sense the world. Very little interpretation or construction is needed around this. It's just an observation primarily. And then this other view, which is constructionist view, which is the process of perception, which relies on previous knowledge and information to construct reality from fragments of sensation. So we are actively constructing what we see, hear, taste, etc. Okay? So the food news is that our perceptual system have a built-in system for determining what information should be or is actually detectable. So the absolute threshold is then introduced, which the absolute threshold refers to the minimum amount of energy in the environment that a sensory system can detect. So each sensory system has an absolute threshold below which energy does not warrant or garner perceptual attention to. Okay, so we then see these different ideas with Weber's law and the signal detection theory. Weber's law is whether a stimulus is detected or not. So this gives the idea of the just noticeable difference. So the premise of this is that the stimulus has to exceed the specifically just noticed difference in order for it to be detectable. Otherwise it will go unnoticed because of differences is too small. So then we see this idea of signal detection theory, which is used when psychologists want to measure the way we make decisions under conditions and uncertainty, which we see this idea being placed in SEAL teams and high-level thinkers and individuals as well. So when we encounter a stimulus called the signal, it is analyzed based on our individual sensitivity and response criteria. So our specific sensation and response to that specific environment. Our individual biases and motivation determine our response to a specific given criteria and play a role in whether we make an accurate detection or not. And you can see Weber's law and the signal detection theory placed below. Alright, so this last section, which is labeled organizing by principles, we look at the figure ground, grouping, and closure, and perceptual set. Figure ground, which is information is automatically divided into a figure and or group, or immediate and background. So the information that is figural is more obvious to us, and the ground is less meaningful. So this idea of grouping then comes into play. Grouping is the large category, contains principles that are used to determine whether stimulus belong in a group of similar stimuli. So we see 4 of these within grouping, proximity being one, which is a stimuli that is close together in space and perceived to belong together. And then we see the next one, grouping ideal, which is common fate, which is a stimuli that move in the same direction and at the same rate and are grouped together. The next stimuli, which is continuity, which is a stimuli that creates a continuous form of grouping together. And then lastly, similarity, which are similar things or stimuli that are grouped together. And then this idea of closure coming into play when organizing principles, which is the principle is a tendency to fill a missing information to complete the stimulus. So our experiences have powerful impact on how we perceive the things. So we need specifically closure in order for us to get that. So we then look at this idea of perceptual set, which is an expectation of what we will perceive. So we use cues from context and experience to help us understand what we are seeing. Another powerful influence on how we perceive things is culture, and how that culture relates to how we live. Alright guys, that was this chapter, which is go ahead, be a little sensitive. I appreciate you guys sticking around. So in this chapter we learned about sensing the world, sight, hearing, touch, smell, and taste, perceptions based on our environments, and different stimuli. So we're going to be diving into a new book. Stay tuned for the next course, which is coming out next week. I appreciate you guys. If you have any questions, any advice, any books you want me to dive into, please reach out to me at TheRealPsychMedia@gmail.com. I appreciate you guys, and have an amazing week. See you guys.